Okay, we will start the lesson right away. So could you please turn on your the camera? Let me know your face. Long time no see you guys. Yeah, I would like to double check your attendance first of all. Number 2, where are you? Not here. No, just double check. Number 2. Number 5. Oh, there may be something coming. I need to wait for him. Number 2. Jack Hiền. Please turn on the camera. One, 2, 3, 4, 5. How about number 5, Clemens? Yeah. All right. So most of you have come back. All of you, right? All right. Nice. Okay, we will start the lesson right away. To start with, it should be this one, right? So last time I just shown you 2 videos I run is for the decomposition of water, right? How to decompose it? By electrolysis. Yes, it's by electrolysis. So by electrolysis is the one way. 中浪欠. Now could you please turn on the camera? Let me know. Yeah, thank you. And the other, what is the other case? What's the other case? Chen Jingguai. The other one, yeah, this, what is that reaction? We've got 2 videos, right? One is the composition of compound to form elements. By electrolysis of water. The other one is the combination of elements to form a compound. So what is the example? The
heat.
Yeah, something.
The heat.
Heat something. Yes, by heat. Heating what? Heating what?
I don't remember it.
You don't remember it, but can you see it? Can you see the screen?
Yes. The iron sulfur.
Iron powder and
yes.
What the other one is? We call it sulfur.
Sulfur, yes.
Sulfur. Okay, so remember, but sulfide, you may see the word sulfide, iron 2 sulfide. What is that? it is a compound, a new substance has been formed. Okay, a compound. That too, it is an element. So in the case will be this: you are going to heat the two samples, the mixture of it to form a compound. Now, before heating, no reaction, but after heating, it forms a new substance. Okay, a black substance. So you may compare the following cases. The first one, iron, is a term of a black or maybe a gray solid. Okay, but for it is a yellow solid. Once I get mixed with it without heating, they would have yellowish gray solid, which means that it seems like a mixing of red bean and the green bean. So you may see some character of the red bean, and also you will see some character of the green bean. How do I know? I would love to do a bar magnet and place it near the mixture, and you will see that only the black powder will be attracted by the magnet. What is the hidden message? Okay, it means that the only iron, right, will be they will still retain its property by being magnetic. Okay, but not for sulfur. For sulfur, before mixing, not attracted by magnet. After mixing it, still not attracted by it. Okay, by having the color, by having the magnetic property that you may know, the iron sulfur mixture will have got two substances. Each one of them will retain its property. Okay, one of them is magnetic, the other is not. And what else is about the action of magnet for the new substance? You claim you have made a new substance, right? So it's best to have a test of it. So first of all, the solid is black, but it's not attracted by the magnet. Okay, it's not attracted by magnet. So by doing so, you start to think, is it? Have we started making a new substance? Okay, so this is our way to think of the idea. Now, I would like to show you further test. Such like iron, if I put into water, it sinks, but the sulfur will have got some sulfur sinks and some floats. But how about iron sulfur mixture? So all iron and most sulfur they will sink, but a little sulfur floats. Well, what is that? It seems like this observation. It seems like this one and this, you add it together. So what does mean by that? Each one of the elements will still hold their own property. How about iron to sulfide? Iron to sulfide, it sinks. So what is mean by iron to sulfide? Iron to sulfide, it is a new substance, right? Sinks. And action of acid. This time that dilute hydrochloric acid, 鹽酸. So what would be the effect of it? So metals, as said before, metal react with acid to form hydrogen gas. Sulfur will not. But a mixture, only the black powder will give hydrogen gas, while the sulfur remains not reactive. How about finally is about the iron to sulfide, very special case. That once we react with acid, they will form some toxic gas. While toxic gas, it will have a characteristic smell. It is bad smell. What is that? 臭蛋味. So it is hydrogen sulfide, 硫化氫. So people, while you do the outing to somewhere places like the places near with hot spring or the places near volcanoes, right? You may smell some smell like this. Okay, it is 硫化氫 bad smell. Okay, it's different from sulfur dioxide. Sulfur dioxide it seems like burning the air surrounding environment after having a place burning firecrackers. 嗰啲就係硫磺味嚟嘅。咁臭蛋味、硫磺味咧有啲似嘅。So but the smell will give you something different. For a hydrogen sulfide gas, some rotten smell, rotten eggs, rotten eggs, 壞咗嘅雞蛋嘅味。But for SO2, a burning sulfur smell. So what is actually about this process? I try to pick up this one as example is that we have produced a new compound. Now, this is what symbolized in submicroscopic viewpoint. What is mean by submicroscopic viewpoint in particle viewpoint? Okay, so for iron, it is solid, while the atoms, they are packed quite tightly. While for sulfur, you may see this. What is that? We call it a crown sulfur, in which the molecular form is S8. While you get mixing of that, it's just like this. So each sulfur molecule would still hold it as sulfur molecule with some iron pieces that mix together like this. So which means that each part of them, if we can successfully separate them, they will still hold its corresponding property. Even though not separated, it can still hold its property. For example, magnetic property. Can you see that? So you may see the black powder, only black powder, but of course with a little bit yellow powder, because they get mixed together, they will still be attracted to it, but mainly it's iron. How about the compound? The compound, why do I say a new substance? Take a look at the packing, a completely new packing in which yellow and the black board, they will stick it alternatively. Okay, indeed that is true. Why is it placed alternatively? It's because of the charge. Iron 2 carry positive charge, and sulfide ion carries negative charge. So of course they would place it alternatively, like this. Okay, because it is an intrinsic attraction. Positive, negative, they would come together. Can you get my point? So to affirm an extended network, so we call that a new substance. A new substance. Is that clear? So if you want to present the whole thing, we love to write a word equation. The word equation, we will show you something like this. Iron to form sulfur, I undergo heating to form what? Iron 2 sulfide. Okay, iron 2 sulfide. And if you want to take a look on the Chinese words, it will give you a little bit different naming system as this. In Chinese, we call that Lao Fa Tit Yi. So 2 means that 2 electrons lost. Okay, so you may find that 2 plus charge. So you may that 2 means plus 2 charge for the iron, which means for each iron atom, it has lost 2 electrons to form its ions. And second, do you find that the naming system in Chinese is different from that in English? Now, first of all, sulfur. Sulfur containing substance, in English, they place it followed by metal. Okay? In the naming system in English, metal comes first and then non-metal. But in Chinese, that is non-metal comes first, followed by metal. Do you realize it? Second is the word changes in the form, changes the form like this, IDE, now which means that altogether is a compound form. For the non-metal, I change its name, while I keep the metal name unchanged. Can you see that? How about in Chinese? There is no such strange arrangement, right? We cannot change any Chinese character, right? If it's sulfur, it's still sulfur, Lao. But I add one more word afterwards. It is Fa. What does it mean by Fa? Can you make a guess? What does it mean by Fa? No idea.
Mixture. Mixture.
Mixture. Somebody saying it is mixture. Mixture, how do you say it in Chinese? Mixture.
混合.
So no Fa, no that term, right? But what I tell you Fa, this means Fa compound. Fa compound. Okay. For example, 二氧化碳 carbon dioxide. So the Fa here means compound. That two elements that will combine to form a compound. Okay, can you get my point? So I know that it is a little bit confusing between a mixture and compound, right? So let's have a look in that sentence, in the symbol. First of all, about the diagram may help. For the diagram, if I say a mixture, they will see there are altogether two types of entity, two types of unit. But they would just simply like red bean, green bean, black bean, they mix together. Can you see that? So each one of them, when you compare with the original stuff, it is pure state. They are more or less the same. Okay, so it is mixture. How about compound? Compound, you may find that a new packing can be formed. Okay, so what we call that is totally different from the constituent elements. So you may see that a new substance has been formed. So what do I say about this whole change? We call that a chemical change. Okay. Now you may find it very difficult, but don't worry about that. You are going to make a difference between mixtures and compounds, right? First of all, mixture, composition by mass, 成分. So if you want to talk about mixture, it is a variable. It's varied, 多變嘅. So which means that if you want to make a mixture of red bean and the green bean, only having one red bean in a bag of green bean is already a mixture. Okay, how about adding two beans? It's still a mixture. Three beans is a mixture, right? That mixture, the composition can be controlled by you, such that you can have different type of mixture. For example, have you ever heard of Karat gold? Or you use the word see, somebody will see that word before, Karat gold with the word K. 18K gold. Have you ever heard of that? 18K gold. You have heard of that? What is that? What's mean by 18? But Gongsan, do you know what's mean by 18K gold? Have you ever been to the jewelry shop and check it what's mean by 18K gold? Have you ever heard of the word 20K gold?
係咪佢嘅純正度啊？
Yes, that's right. Which one is more pure? Which one is pure?
24K, 24K.
Yes. What is the highest purity? Is it 24? Yes, 24 is the highest purity. Do you understand? 24. Now, indeed, you may have heard of that term 9999. 9999 gold, right? Why is it say that 9999 gold? Is because of the percentage. It's 99.99%. Okay, it's nearly pure. So 24 karat gold, which means that the pure is nearly pure gold. But for 18K, what does it mean by that? A little bit impurity inside. So what can be impurity with that impurity? We've got 18 parts of gold plus 6 parts of something, of silver, for example, and you can get 18 karat gold. Do you understand? So why do I need to put 6 parts of silver to it? Why?
Cheaper?
More harder.
A little bit cheaper, as well as, have you ever experienced of touching those real gold, pure gold, and karat gold? Do you know the texture, the difference between that? Now, what I'm referring to is the hardness. Do you know which one is harder? You know.
18K gold 應該硬啲。
Yes, right. Yeah, because it's impure, right? So, it is the mixture. It tells you the example of mixture. 18 karat gold, I can also make it cheaper, just like 14K, right? It's not trial society terms, but you can make the purity of the gold even lower. Okay, so you may find that a mixture, it varies. The composition of different substances inside vary. It can be changed by yourself. Carbon compound, it is fixed. It is fixed. How fixed is it? For example, if you want to talk about carbon dioxide, I'll write it as CO2. Why? It's because carbon dioxide is in the form one
Two
carbon
oxygen
to
atom.
two oxygen atom mixed together. So the ratio must be in 1 to 2. But you may also think of like this: carbon monoxide, while carbon to oxygen ratio is just 1 to 1. So whenever you talk about that compound, so you may see from the symbol, from the diagram, that the number of atoms ratio in the two inside is different. Is still the same. It's keep fixed, no change. Okay, but once I change the ratio, here comes another substance.
Okay.
Questions?
No.
Oh, so far understand, right? So this is what you know about mixture and compound. Is that two is different. Second, changes in formation. How can we produce it? For mixture, simply by mixing, no chemical change occur. No chemical change. But for the formation of compound, usually it involves heat. Heat is given out or maybe absorbed when the compound is made. What does it mean by given out? You mix it, for example, explosion, or it will become hotter. You call that heat is given out. What does it mean by heat is absorbed? So strange that term, right? What does it mean by heat is absorbed? It become cooler? The answer is no, because once it's cooler, normally the reaction cannot proceed so easily. So how? Just like the last case, I need what? I need heat. I need to supply heating, right? I need to heat it. I need to heat it before a compound is formed. So we call it heat is absorbed. I need some heating. Do you understand? Now, how about number 3, melting point and boiling point? Now, for mixture, they doesn't have a sharp melting point and boiling point. Why? Because, for example, I've got iron and sulfur mixture. Iron itself has its own melting point. Sulfur has its own melting point. So even though I mix it, the melting point is still the same as its own elements. Okay? For example, iron will have a melting point more than 1000 degrees. How about sulfur? It's just several hundred only. So once I increase the temperature less than 1000 degrees, only sulfur melts, but not for iron. Can you get my point? So we call that not sharp melting point, because from you yourself, you look at the mixture, you may find that part of them start to melt, but not all. So we call it not sharp. But for compound, it has a sharp melting point because it is a totally new substance. Okay. How about changes in formation? Any change? Now, indeed, no chemical change. All of you, please mark it down. A little bit wrong about the placement of the words. No chemical change, but we have got a chemical change when you are having a formal compound. As said before, whenever I have got a compound form, it involves heat. And the general property, each consistent element will retain 保留, would keep its own property. Just like iron and sulfur, from the color, from the reaction, etc. If you want to describe as a color and density, etc., we call that a physical property, appearance, right? If you want to talk about chemical property, which means that the reaction with acid, for example, right? If you describe there is a chemical change, it is what we call it as a chemical property. Okay, and For the compound, the properties, they are entirely different from those of its constituent element. Excuse me. So you may find one example. For example, carbon, oxygen, and carbon dioxide. You know, you have got the equation like this. So, but what is the difference between them? Carbon, black, solid. Oxygen, colorless gas. And carbon dioxide, it is also a colorless gas, right? But for oxygen and carbon dioxide, they are still different. Can you give me some other different property between carbon, oxygen, and carbon dioxide? How? 有冇啊？睇下文識答先呢個。有冇 up 得到一個多一個嘅 property 係唔一樣嘅 ？Carbon, oxygen, carbon dioxide。翁成軒。
Yes.
Try.
Can you repeat the questions?
Can you tell the difference in the property in carbon, oxygen, and carbon dioxide, which make a difference? That three, they are different. Now you may find that the physical state and the color, they will make you confused. For oxygen and carbon dioxide, they're different, right? But the property, they are the same, right? In terms of color. So how can you make a difference between, for example, oxygen and carbon dioxide?
Oxygen is flammable.
Oxygen is flammable. Okay, who says so? Sorry, can I have an English? Who?
Damien Poon.
Hey, now take a look. Oxygen is flammable. Carbon dioxide cannot be burned. Agree?
Yes.
Okay. Sorry, no. Oxygen cannot be burned. Oxygen is not a fuel. Oxygen is just a supporter of burning. This one is not flammable. It's just supporter of burning. Okay, so only the carbon can be burned. Flammable, supports burning, and this one non-flammable. Okay, what else? What else can you think of? For example, lime water. Carbon dioxide will react with lime water, right? But not for oxygen, but not for carbon. Can you get my point? So can you make the difference between them? So if you want to take a look on the first one, for example, the first one, what we call it as a physical property, 物理特性, it describes the appearance of it and describe, for example, melting point, boiling point. Also, they are just example of physical property. How about the second and third one? We'll call it a chemical property. Why? Because if you want to describe that, further describe that substance, you may use chemical change to describe. So we call that chemical property. Do you understand? So if you want to say so, you may think of the way to separate it. For mixture, because they have just keep their own property. So simply using some physical method can help. But if you want to separate it, if it is compound, I use chemical method. How? What is an example of physical method? For example, distillation. Why? If I want to make a salt solution and I want to separate it into salt and water, I use distillation. Why? Because distillation only involves what? Boiling and condensation of water, right? So this is what you know about the physical method. Okay, how about chemical method? How about chemical method? You may think of one example. What is the chemical method? Separate it. Yeah. Electrolysis. Okay, electrolysis. 電解係嘛？ It is one of the example. 電解 electrolysis, using electricity to break down something. Electrolysis of water. So what will be the form? I form hydrogen gas and oxygen gas. Okay, I separate H2O into hydrogen gas and oxygen gas. Any questions so far? Easy? Difficult? Or what? Any questions? Now, if not, now you take a look at the chat point. Take a look at the chat point. Classify the following substances as elements, compounds, and mixture. Take a look on that. You may find that here. Now take a look and try to see if you can manage. But it is quite confusing to classify them because they are of different categories, right? So the way to classify is mainly by the following: elements and compounds as a group, mixture as a group. Why? Now this one, it is a somewhat pure, and mixture, it is somewhat impure. So you use this to classify it first. Do you understand? Okay. And Jiu Xinyan, take a look on the first one, egg. An egg. What do you think? Is it a pure substance or mixture?
Pure substance.
Pure substance. Pure egg.
No.
Pure substance. What do you think is pure substance? What is contained inside an egg? Now, I know that it's rather confusing. How you say that an egg is a pure or not? Now, it depends on how would you think it as a unit. Okay, if you say that egg is a unit, okay, so you may think that it is only one thing, but our scope chemistry viewpoint is to have a magnifying glass and try to take a look at the chemical inside. So what contains inside an egg?
Water.
What else?
Oxygen.
Oxygen. A little bit, not too much. What else?
Carbon.
Carbon. In terms of what? Is it black? When you crack open the eggshell, is it black? No. Carbon is not an element. Carbon is in the form of what? Have you ever heard of the term protein?
Yes.
蛋白質.
Yes.
蛋白質 is just one of the compound found inside. Okay, so what I just mentioned is the substances found inside an egg. So that mix together. So the answer is mixture. You understand? We call that mixture. Remember what you are having is to take a closer look inside. Now, I'll give you another example. Is air. Is air a mixture, element, or compound? The answer
Mixture.
is, yep, it's a mixture. It's a mixture of what?
Nitrogen.
Elements and compounds. Why do I say that an elements and compounds? You can make a distinguish that. Elements refer to nitrogen gas, oxygen gas is a argon is elements. How about compound? Carbon dioxide.
Carbon dioxide.
Yep, water vapor, etc. Right? All those they are just compound. So air itself, we do not treat it as an entity. We do not treat it as a whole unit. Okay? We try to take a look at the chemical inside. So can you get my point? Can you get my point? 志川 can you get my point?
Yes.
我哋睇係睇咩咧？我睇入邊嘅化學成分。我哋睇下啲化學成分，咁隻有邊唔一樣嘅，而佢哋之間咧就咁撈勻啫。 冇再有化學結合㗎啦。咁我話呢個咧就叫混合物。咁如果咩叫化合物咧？例如係咩咧？呢度有冇化合物嘅例子啊 ？Any examples of compound?
Concrete.
Concrete. Is it? Okay. Is it concrete?
Yes.
What do you think is concrete? Concrete,
Mixture.
it's just a mixture again. Why? Because it's a mixture of something, just like sand, cement,
Water.
stone, water, etc. So it is a mixture of different things. So it is what we call it as concrete. It's a mixture. Okay, but carbon dioxide, it is a compound. Why? Because inside that, if you have a bottle of carbon dioxide, you can only see such, right? If you can have a real, if you can really manage to look at the particle viewpoint, you may see one solid sphere on, together with two. While with a bottle, we have got so many.
咁如果個 oxygen 後邊係 O2 嘅話，咁 O2 應該算係一個 compound 定係算係一個 element？
You mean carbon dioxide or oxygen gas？
我只係講緊即係齋一個咯，即係譬如 nitrogen 咁嘅 N2 咁樣咯。咁佢算係一個 compound 定算係一個定算係一個普通嘅 element？
How about the other students? What do you think? Now you may know that argon itself is not.
I think it is element.
It's still an element, or is it a compound? Now, in order to answer this question, now the same question applies if you're talking about ozone. Ozone, Chinese we know what is that? 臭氧. Ozone. Have you ever heard of this term? Ozone. Some smelly gas, pale blue smelly gas with formula O3. Now O3, what is that containing? We've got 3 oxygen atoms. You stick it like this. Okay, O3, 臭氧. So 臭氧, inside that we can have 1 molecule of ozone having 3 oxygen atoms. While you see the 3 oxygen atoms, are they belonging to the same type? The other one is yes, same type of atom inside that. So it belongs to our classification as element. An element is a pure substance that cannot be split into anything simple by chemical method, or a substance which contains only one kind of atoms. So, according to this definition, ozone, oxygen gas, even though the formula, they will show it as 2 and 3. Okay, so we still categorize it under the term elements. But why do I say it's O2 and O3? It's because only have that type of combination will make it stable. Why is it stable? Why do Mr. Chin said it's stable? Originally, oxygen atom is not stable. Oxygen atom we have got how many electrons are there? 8, right? So you may count it as 2, 6, but you want to look for 2H, right? So we have got two electrons missing here, right? We've got missing electrons, no such electrons here. So we have got just that. So they may try their very best to find another oxygen atom to make both having H electrons. So it is by sharing of electrons. So it's a little bit out of the syllabus for Form 3, but how? It's done by having the sharing of electrons. We've got share 2 electrons. They ask the other oxygen atom, the electrons, to share the 2 electrons. They come together. They will form it as 8. How do I count it as 8? they would treat the overlapping area, those electrons as itself as well. So you may find we've got oxygen 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So they will treat it as octet to them. While this one is stable. You understand? But for argon, you did not make it as 2. Argon, do you know the electronic configuration? Is 2, 8, 18 electrons. So the final number is 8. Is already stable. You need not lose or gain electrons to make it stable.
The noble gases.
Yeah, noble gas, we call that monoatomic. Why is it mono? Mono means 1. But for oxygen gas, we call it diatomic. Why you say that di? Di means 2. Okay? You got it?
Yes.
How about the other compound found in these 6 examples?
H2.
H2. H2 is a compound.
No. H2 is an element.
Yeah, H2 is an element. How about ice?
H2O.
Yeah, H2O is also an compound. I write down a solid only. The packing of ice, it gives a regular arrangement, but inside that we still have this combination, right? We've got 1 big ball, 2 small ball. The big ball represents oxygen, 2 small ball hydrogen atom. So ice is the compound. Okay, how about iron and nitrogen? And 2 Fe. Inside that, after writing the symbols, all other symbols that mix up to the substance. So it is an element. It is the element, okay? Can you get my point? But for iron, you say the element, but if you write down as iron ore, it's a mixture. Okay? Because ore, it get mixed with some other things. Can you get my point?
Yes.
Hello? How about question 2? Sodium chloride can be reacted by reaction in sodium with chlorine. The reaction can be represented by the word equation like this. Identify each of the 3 substances in the equation as element, compound, or mixture. Sodium chloride.
Sodium chloride is element.
Yep.
Sodium chloride is
compound.
Yep, good. 2 of them is element and this one is compound. It's compound, okay? Rock salt occurs naturally. You find a mixture of sodium chloride and sand. What is meant by rock salt? So explain why the sodium chloride and the sand in the rocks can be separated by physical method rather than chemical. Okay, instead of chemical method, I use physical method. I can separate it. Why?
It is a mixture.
Yeah, this forms rock salt. It is a mixture. Mixture of what? Of sand.
Sand and sodium chloride.
Yep, and sodium chloride. Anyone who know the chemical name for sand? Sand, we have got a chemical formula, SiO2. So what is that? It is a silicon dioxide. It's not a mixture, it's a compound. It's another compound. So rock salt is a mixture of 2 compounds. It is a compound. It is also a compound. Now, don't worry. Whenever I write as the formula like this, it is a chemical combination of the 2. So we call it compound. Now, how would you use physical method to separate it? How to separate? Form 1 IS. You know it. Check its property. Because sand and sodium chloride retains its property. So we use what? We try to
Sodium chloride can be Mixed with what?
Can be what?
Mixed with what?
Mixed
It's
with
soluble in water.
or soluble. Use the word soluble. Yes, that's right. So you are going to solve the mixture into water. So what happened to it? We've got two
Filtered.
cases. SiO2, they will stay as solid. Okay, can be collected later on. How?
Filtration.
Yep, by filtration. 過濾法. So filtration, it is a physical method. How about sodium chloride? It is soluble. It dissolves in water. So
Distillation.
how can we collect it?
Distillation.
Distillation. What else? Besides using distillation, you may simply use evaporation. Can get the sodium chloride. Why? I don't need any water. I need sodium chloride only. Okay. So simply evaporate until dryness can help. Just like salt field, 有啲鹽田啊. So they are doing something like this. They pour in some seawater and put it into a big pond and let the sunlight help speed up the evaporation of water. And leaving behind, I get the sea salt. Do you understand? So you may see dissolving, filtration, evaporation. All those, they are just physical method. Can you get my point? So you can separate it by physical method. Can you see that? 見唔見到呢幾個都係啲物理方法嚟嘅。The first one, dissolution, filtration, evaporation. That three, they are physical method. No need to have any chemical change. Do you understand? Do you find it challenging? A bit? Any questions? Now it comes to no, yeah. 係咪有嘢問？冇啊嘛，好，寫晒未呢度？你寫晒就出聲，話俾我聽。
未寫晒。
你寫完 OK 得。好，咁啊。咁啊，等緊嗰陣時咧，我就拎埋有少少嗰啲，我俾埋份 exercise 俾你啦。Okay, you may find it in the chat box. All right, I will also post it into WhatsApp later. Oh, that's me. Okay, shall we move on? On the last topic is a physical change and chemical change. Now, you may also refer to the book. While these 2 pages they are just supplementary information. So, physical change is a change that we have got no new substances are formed. Now, for example, I change in shape, I change in volume, I change appearance, I change the state of the matter, which means solid, liquid, gas, is also an example of physical change. So, for example, boiling of water, vaporization of dry ice, if a piece of paper tear into pieces, okay, they are also physical change. But the key point is whether or not they are new substances formed, okay? Okay, so the next one is chemical change. As said before, tear the paper into halves is just a physical change. But once a burning is a chemical change. Why? Because burning paper they will form CO2, H2O, carbon monoxide, etc. So they will give you totally new substances when you compare with paper. Paper itself will have got a chemical, we call it cellulose, 纖維素, right? So that too, they are different. The similar case we find it for chemical change is the electrolysis of water. So water is H2O. They will be broken down by electricity to form hydrogen gas and oxygen gas. So in this case, we have got hydrogen gas and oxygen gas. The property is entirely different from water. So we call that new substance is formed. So that's why you may see from the definition. You may have a change in which one or more new substances are formed. We will call that as chemical change. Okay, so during the change, it involves quite large amounts of energy being released or absorbed. It can be heat, it can be light, or it can even by electricity. They would have been evolved. So in short, the main difference between chemical and physical change is to check whether there are new substances are formed. If there are new substances are formed, it's a chemical change. If not, physical change. All right, is that clear? So, checkpoint about final 4 examples. State whether each of the following is a physical change or a chemical change. Give your answer.
A is chemical.
A, chemical change. Yes, chemical change. Why?
Burning.
Because when magnesium
Yeah.
it produces
A new substance is formed. Yeah, we'll call it what? Magnesium.
Magnesium oxide.
Good, magnesium oxide. So indeed, the reaction comes like this: magnesium plus oxygen in air at high temperature to form magnesium oxide. So this is somewhat powdery, a white powder for magnesium oxide, while for magnesium it's just like a silvery strip. Of course, you know that oxygen is colorless gas. Yes, that's right. How about B? Water boils at 100 degrees.
Physical.
Physical, why?
No new substance are formed.
Yep, no new substances. So how you know there is no new substances? What change? What are they undergoing? They are just turned
Evaporation.
Evaporation. Is it evaporation?
Yes.
Vaporization.
Boiling, turned into water vapor.
Yeah, vaporization, not evaporation. Evaporation means something else. You know the meaning difference in the meaning between the two?
Yeah.
Some difference between the two terms. Vaporization would pass through the substance through the boiling point. So it may involve heating. For evaporation, no need. Now, just like wet clothes hanging dry, okay, the water evaporates. But I will not tell the wet clothes hanging dry, the water inside boils. Can you get the point? So the water boils at 100 degrees, which means that we are just have a change in what we call that physical state. Change in physical state from liquid to gas. Do you understand?
Yes.
Let's see. Water changes to ice in the freezer.
Physical change.
Yeah, physical change. Why?
Turned into a solid state.
Yeah, the same argument as B, right? No new substances are formed again. It's just it's a change in physical state. But this time it is from what? From liquid turned back to solid. You understand? How about the last one? Iron rust.
Chemical change.
Chemical change. What is the chemical reactions? Do you know?
Oxidization. Oxidization.
Oxidation. We call it oxidation. A new substance is formed. new substance is formed. So the chemical equation is a little bit complicated. Iron plus oxygen and water to form a new compound. The new compound, we call that rust. While for the chemical name, is not called it as rust. We will say it as hydrated iron 3 oxide, right? Very complicated name with a formula Fe2O3.XH2O. I just want to scare you, not choosing chemistry. So hydrated iron 3 oxide. Okay, so that's why
free 係咪 try 嘅意思啊
？Iron 3, that 3, no. Iron 3, that 3 means the charge of iron. The charge of iron is +3. Oxide is 2 minus. I want to make sure that the charge balance, so I make it as 2 to 3 ratio. So we will got it 2 and 3. You may know it in Form 2, in Form 4, right? In Form 4 chemistry. That 2 and 3 means the ratio. I want to make the overall charge balance. Okay. Any questions so far? Easy? Yeah. Now I've just given you the task sheets. Okay, you may click them out and try to see what is that. I just show you one questions only. I found some of you may have confusion about different, especially mixture and elements, right? So I would like to show you this one. Can you see that? Yeah. So this is the exercise. I would like to draw attention, and I would like to show you this one. Question 5, the last question. Now this is an exam type question, right? Instead of just telling you what is happening, the best way is to show you graphically what is happening. Okay, tell me A, B, C, D. Which of the diagram best shows a mixture of 2 elements?
A.
You may type your answer in your chat box. Let me know your thoughts. Just type your answer. I just want to have a statistics. Try to see if you can really understand what is that. Okay, all of you, could you please type your answer on the chat box now? Tell me. Nice, nice. It seems that most of you have got it as A. Yeah, A is the answer. Mixture of 2 elements. Mixture of 2 elements. The answer is A. How about B, C, and D? What are they? The best way is to get to know what is B, C, and D. You get to know, you have to tell me what that is. Who else? 23. Who is 23?
Yes.
Or
梁柏強
Oh, Lan Pak. Tell me, B, what is that?
Compound.
Compound. Which one is a compound? Do you have a pen? Can you circle it for me? Which one is a compound? Whole thing is a compound? Oh, this?
Yes.
How about this?
Element.
Yep, compound. Here, element here. And I put it like this way. How do I describe this B? Any special linkage between that compound and element here? Any linkage? It seems they are quite far apart, right? So it's not a chemical combination. So what is that?
Mixture.
Yeah, good, very good. Mixture of 1 element and 1 compound. Can you get my point? So similarly, you should know C and D, right? C is what? Just one type, right?
Element.
Yeah, element, but it is a diatomic one, right? And D?
Compound.
Yes, compound. 4 different units, they are the same. So you get my point. So a very good example, please put 1 million star here, right? 1 million star here. I would like to ask them again in the quiz or maybe exam. Okay, go home and take this as an exercise. Okay, I will tell you the deadline through Google Classroom. Any more questions? It's time to hand over to the last lesson.
如果冇 printer 接唔接受用紙寫啊？
You may use the single line paper and write it, or you can use your iPad to write on it and capture it and do it as a PDF, send it back to me. Okay, what I need is PDF format. Single line paper also accepted. Okay, any more questions? Oh, it's time to pass.
即係可以直接攞支 Apple Pencil 喺上面寫啊？
Yep, you can. Okay, no more questions?
No.
I'll see you guys next lesson. Bye-bye. Bye-bye.
拜拜。
2拍。